Namaskar, dear students, welcome. We are discussing exact differential equations. We are solving problems on exact differential equations. In the last class, we solved some problems of some differential equations which are not exact, but such type of differential equations can be made exact. Today, I am going to discuss another method. The method is the differential equation is not exact, but it is homogeneous. You know that a homogeneous differential equations can be easily solved by putting y is equal to vx or dy by dx equal to v plus x dv by dx, like that. Then, but such type of differential equations can be solved by converting the differential equation to exact differential equations. Suppose this is the method 3. A differential equation is not exact, but it is homogeneous. A differential equation of the form. Suppose a differential equation of the form m dx plus m dy equal to 0 is not exact. Suppose is not exact, where m and n are functions of x and y. This differential equation is not exact, but the differential equation is not exact, but it is homogeneous. It is homogeneous. अब तो homogeneous differential equations easily solve कर सकते हैं. What is the homogeneous differential equation? Which can be expressed in the form dy by dx equal to f of y by x. If the differential equation can be expressed in the form dy by dx equal to f of y by x, it is homogeneous. With such type of differential equations can be easily solved by putting y is equal to vx or dy by dx equal to v plus x dv by dx, v plus x dv by dx. Then put here v plus x dv by dx, this is nothing but fv, or x dv by dx equal to fv minus v, or you can separate the variables. You can easily separate the variables, and after separating the variables, just integrate it. Then you will find a relation between v and x. Then replace v by y by x. Then you will get the solution, which will include one arbitrary constant. This can be solved like this, but in an alternative way, such type of differential equations can be solved. If it is homogeneous, then we find if mx plus ny is not equal to 0, mx plus ny is not equal to 0, then 1 by mx plus my, 1 by mx plus ny is integrating factor. Mx plus 1 by mx plus ny is integrating factor. If you multiply the differential equation by the integrating factor, then the differential equation becomes exact. Means del m by del y equal to del n by del x for the new differential equation after multiplying it by the integrating factor. Then you can find the solution by integral m dx treating y as constant plus integral n dy taking only those terms in m which are free from x. This is equal to constant, or like that. Or since it is exact, it can be expressed in the form dy du equal to 0, where u is a function of x and y. After multiplying by the integrating factor, this differential equation will become exact. Then in this method also, we can solve a differential equation which is homogeneous but is not exact, but it can be made exact after multiplying by the integrating factor. Let us try to solve this problem. Suppose this equation is, it is homogeneous. It is 2 plus 1, 3, x to the power 1, 2 plus 3, 3, 3. This is homogeneous. This differential equation can easily be expressed in the form dy by dx equal to f of y by x. It is homogeneous. You can solve the differential equations by putting y is equal to vx like that. Or it is, since it is homogeneous, now check that mx plus ny. If mx plus ny is not equal to 0, then 1 by mx plus ny is an integrating factor. Means if you multiply the differential equation by 1 by mx plus ny, the differential equation will become exact. Here m equal to, you see, here m equal to x square y minus twice x y square, n equal to minus x cube minus thrice x square y. This is equal to minus x cube plus thrice x square y. Mx plus ny. What is mx plus ny? Mx plus ny is x square y minus twice x y square x plus minus x cube plus thrice x square y into y. This is equal to x cube y minus twice x square y square minus x cube y plus thrice x square y square. Now these two terms will be cancelled. You will get x square y square. Therefore, the integrating factor is x square. Integrating factor will be equal to 1 by x square. Therefore, integrating factor equal to 1 by x square y square. Integrating factor will be equal to 1 by x square y square. If you multiply the differential equation this by the integrating factor, then the differential equation will become exact. Multiplying 1 by this, multiplying 1 by integrating factor, which is 1 by x square y square, we get x square y minus twice x y square divided by x square y square dx plus, it will be minus x cube plus thrice x square y divided by x square y square dy equal to 0. You will get this one. Or you may write 1 by y minus 2 by x dx. 1 by y minus 2 by x dx plus minus x by y square plus 3 by y dy. This is equal to 0. Dy equal to 0. 1 by y minus twice. 1 by y minus 2 by x dx. 1 by y minus 2 by x dx. 1 by y minus 2 by x dx plus minus x by y square plus 3 by y. Minus x by y square plus 3 by y dy. dy equal to 0. The way you may check this one. X by y square plus 3 by y equal to 0. This one. This is an exact differential equation. If you put here, it is m. If it is m del m by del y, what is del m by del y? Equal to minus 1 by y square. What is del m by del x? This is equal to again minus 1 by y square. It is exact. Therefore, it is exact. It is an exact differential equation. You may solve this. Just I have told you that this is an exact differential equation. M is equal to this, n is equal to this. You can solve in that way also. Integral m dx plus integral n dy equal to constant. Taking only those terms which are free from x. Now, you can write it as 1 by y dx minus 2 by x dx minus x by y square dy plus 3 by y dy equal to 0. You may write like this. Or 1 by y dx minus x by y square dy plus 3 by y dy minus 2 by x dx. You may write like this. Now, this means it is y square. It is y dx minus x dy plus, you may write 3 d of log y minus 2 d log x equal to 0. This means you may write it as d of x by y plus d of log y cube. You may write like this, minus d log x square. You may write like this. This is equal to 0. Or d of x by y plus log of y cube by x square. This is equal to 0. You may write like this. Integrating, you will get integrating x by y plus log of y cube by x square equal to constant. Integrating, you may write like this. Or x by y plus 3 log y minus 2 log x. This is equal to constant. Any constant. Any constant. You may write it as x by y plus 3 log y minus 2 log x equal to constant. Therefore, this is the solution of the differential. Let us take another problem. Let us take this is again homogeneous. 2 plus 1, 3, 3, 3. Homogeneous. It can be easily expressed in the form dy by dx equal to f of y by x. Since it is homogeneous, it can be easily solved by putting y is equal to bx like that. Or now let me take mx plus ny. If mx plus ny is not equal to 0, then 1 by mx plus ny is an integrating factor. This means that multiply the equation by the integrating factor, it will become exact. Now, here m equal to x square y n equal to minus x cube plus y cube. X cube plus y cube. Mx plus ny equal to mx x cube y plus ny minus x cube plus y cube into y. This is equal to x cube y minus x cube y minus y to the power 4 equal to minus y to the power 4. Therefore, integrating factor equal to 1 by mx plus ny, which is equal to minus 1 by y to the power 4. Integrating factor will be equal to minus 1 by y to the power 4. Integrating factor is this. Multiply, suppose this is number 1. Multiply 1 by the integrating factor. Multiplying 1 by integrating factor. Integrating factor, which is equal to minus 1 by y to the power 4. We get, multiply this by minus x square y by y to the power 4 dx. It will be plus x cube plus y cube divided by y to the power 4 dy. This is equal to 0. This is equal to 0. Or minus x square by y cube dx plus x cube by y to the power 4 dy plus 1 by y dy equal to 0. This is equal to 0. X cube or x cube by y to the power 4 dy minus x square by minus x square y cube dx plus, it can be written as d of log y. This is equal to 0. You may write like this. Now you see y to the power minus 4. It is y to the power minus 4. Differentiation of y to the power minus 4 is y to the power, integration of y to the power minus 4 is y to the power minus 3 by minus 3. Or you may write here x cube d of y to the power minus 3 by minus 3 minus 1 by thrice y cube. Can I write like this? For 1 by y to the power 4 dy, you may write like this. Minus 1 by 3, it will be y to the power minus 3. The integration or differentiation of y to the power minus 3 is minus 3 y to the power minus 4. Minus 3 will be cancelled this. Plus here minus 1 by thrice y cube, you may write like this. Minus 1 by thrice y cube into d of x cube. What is d of x cube? X cube is thrice x square. 3 will be cancelled. Ultimately, you will get, what is this? D of x cube is thrice x square dx. Thrice x square dx. This 3 will be cancelled. Minus is already there. X square by y cube d plus d of log y equal to 0. This is equal to 0. Means, see this one. First function x cube, differentiation of the second function, minus 1 by thrice y cube, plus differentiation of the second function, minus 1 by thrice y cube, into differentiation of into second function into differentiation of the first function. This can be written as d of first function into second function. First function into second function. This means you may write here d of first function x cube, second function 1 by thrice y cube. You may write like this. X cube minus 1 by thrice y cube plus d log y plus d log y log y. This is equal to 0. Or you may write d of minus x cube by thrice y cube plus log y. This is equal to 0. It has been expressed in the form d of u equal to 0. Integrating we get minus x cube divided by thrice y cube plus log y equal to c. This is the answer. Or for c, write it is as log k, suppose log k, then minus x cube by thrice y cube plus log y. This is equal to log of k. You may write log of k. Or log of y by k. This is equal to x cube by thrice y cube. Or y equal to, you may write k into e to the power x cube divided by thrice y cube. You may express the answer in this way also, in this form also. We have solved two problems today. The differential equation is homogeneous, but mx plus ny is not equal to 0. Multiply the differential equation by 1 by mx plus ny, it will become exact. Once it becomes exact, then you can easily express in the form du equal to 0. Integrate this, u equal to constant. Therefore, dear students, I want to stop here.